In this video, you're going to learn about exponents. Now, exponents is a way to represent multiplication in a quicker fashion. So if you're multiplying the same number over and over and over again, instead of writing it out over and over again, you could use exponents instead. So here's how they work. You have maybe what's called the first power of 5. So the first power of 5, what that means is you have 5 and then a little 1 written above it. And that means you have 1 5 multiplied, which would just be 5. Alright, so in English, you would read this as 5 to the first power. Alright, you can then have the second power of 5, which means we would have 2 5s multiplied together. And you'd write that as 5 and then with a 2 up above. So the 5 with the 2 up here means you have 2 5s multiplied together, 5 times 5, which would equal 25. And in English, you can read this as 5 to the second power. Or another way of saying this is you can express this as 5 squared, or the square of 5. So the 2 means squared. That's the other word for it. Alright, if you have third power of 5, that means you have 5 with a 3 above it, and that means you're multiplying 3 5s together. So you have 5 times 5 times 5, which would be 125. So in English, you can read this as 5 to the third power, or a special name we give to this as well with the 3 would be 5 cubed, or the cube of 5. And then this can continue. We can have the fourth power of 5, which means we have 5 and then a 4 up here, and that means we have 4 5s multiplied together. So 5 times 5 times 5 times 5. And in English, we could read this as 5 to the fourth power. Alright, and then this would continue. You have the fifth power, sixth power, seventh power, etc. So whatever your exponent is up here, then that is the number of numbers we're multiplying together. Alright, so let's talk more about exponential form. Here we have 5 to the fourth power. The number 5 would be called your base. So base usually means bottom, so the 5 is at the bottom. So that's your base. And then 4 is called the exponent. Okay, so whatever power you're raising it to, that is your exponent. So 5 to the fourth power is called exponential form. And then when you multiply it out like this, 5 times 5 times 5 times 5, that right here is called expanded form. So we have exponential form where you write it with an exponent, and then expanded form means you expand or multiply it out like this. So in general, if b is any real number and n is any positive integer, the nth power of b is written as b to the n power. So b with an n for your exponent. So in math notation, we have here b to the n power equals, and then you keep multiplying b over and over again. So b would be your base, and then n would be your exponents. And then right here, these b's that we're multiplying together, those are called factors. And there will be n of them. So whatever this number is for your exponent, that is the number of factors that we have. So if we had, let's say 5 times 5, the 5 is called your factor because that's where you're multiplying together. Alright, here we have an example where you are told to write in exponential form. So we see that there are 5 4s. So when we write this, we can write this as with a base of 4, and then 5 would be your exponent. So this expression right here means we have 5 4s multiplied together. If we had 4 a's multiplied together, we would write this as a to the fourth power, where a is your base and then 4 is your exponent. Here's another example where now we have numbers and we also have different variables in here. So we can multiply the numbers together negative 3 times 2 to get negative 6. And then we have a p here and a p here and then 2 p's over here. So there are 4 p's multiplied together. So I can write this as p to the 4th power. And then the q's, we have 2 q's multiplied together. So multiply this by q to the 2nd power because there are 2 q's. So my expression we see written right here. Now we can use this in different scenarios, one of which would be with geometry. And here you're given a rectangle, and you know the length is 3 times x, and the width is x. So you're trying to find the width and the length given this information. We know the length is 3 times the width. Well, we can use our area formula, which says that the area of a rectangle is the length times the width. And we can plug in these numbers. So the length is 3x, the width is x. So we have 3x times x to get the area. And then x times x can combine. We have 2 x's, so we have x to the 2nd power. And then many times you would be given the area, and then you can use that information, plug it in to the equation, and then we can solve. So that's going to be later in algebra, but it's important to know how to set up the equation as you see here, and make sure you know how variables work when you multiply them together. Now, a word of warning as we continue. You need to be cautious when an expression contains both parentheses and exponents. For example, we have 2y to the 4th power. With parentheses, whatever is outside of that exponent, goes to everything in parentheses. So we see 2y to the 4th power means we have 2y times 2y times 2y times 2y. Alright, that's what this expression means. So 4 is the exponent of the base 2y. Alright, 2y is your base. However, if you have this expression, 2y to the 4th power, without parentheses, we are following order of operations. So we do parentheses first, and that's why this was the way it was for the first example. After that, we do exponents. So the 4 just goes to the y. So that would be your exponent. Y to the 4th power is y times y times y times y. And then after that, then we multiply and divide. So that means after your exponent, after y to the 4th, at that point, that is when you multiply by 2. Alright, so make sure that you are understanding that the exponent goes to whatever it is next to. So if it's next to the parentheses, it goes to everything in parentheses. If not, like in this case, it's just going to go to the y. Alright, so 4 is the exponent of just the base y. Okay, next we need to know how to evaluate with exponents. So here we are told to find x to the 4th if x equals negative 3. So all I do is I plug in negative 3 in place of x. So instead of x to the 4th power, we have negative 3 to the 4th power. And negative 3 to the 4th power, notice the parentheses, because that entire quantity is being raised to the 4th power. We have negative 3 times negative 3 times negative 3 times negative 3. So the negative times negative makes a positive. Negative times negative again makes another positive. So we have 3 times 3 is 9, times 3 is 21, times 3 is 27, times 3 is 81. So my answer is going to be 81. Alright, now we will combine that with multiple operations. So it's important to be reminded of the order of operations. Make sure we remember what is the process. So don't forget, we begin with parentheses, and then we do exponents, and then we multiply, divide, and then we add and subtract. Alright, so here's an example. We have negative 2 to the 4th power. Now be careful here because the 4 is just going with the 2. All right, if it was going to the negative as well, if it's going to the whole number -2, you need parentheses around -2. But it's not. So the 4 goes with the 2. So we have 4 2's and then a negative out in front. And the reason is because we're doing exponents first. So we do 2 to the 4th power first, and then we do multiplication, which would be what we have here. It's a negative times the 2 to the 4th power. So 2 to the 4th power, it would be 16, and then a negative comes after that, so this would be a -16. Whereas here, we have -2 to the 4th power, but the entire number -2 is being raised to that 4th power. So in this case, -2, we multiply that 4 times. So we have 4 -2's. And so the 2 negatives make a positive, 2 more negatives make another positive. So here we multiply 2 times 2 is 4, times 2 is 8, times 2 is 16, and it's going to be a positive 16. All right, so note the difference between these two questions. Next we have 2 plus 4 squared. So we begin with parentheses. So we do the 2 plus 4 first to get 6, and then we square it, meaning we take 6 times 6, which would equal 36. And note the difference between that question versus this question. Here we have 2 plus 4 squared, but without parentheses. So we need to follow order of operations. We begin with exponents first. So 4 squared we do first, and that gives me 16. And then I add 2 plus 16, and that gives me 18. All right, so be careful that you're following the order of operations as you work with exponents. All right, next you're told to evaluate 3a plus b squared if a equals 2 and b equals -3. So we begin by plugging in 2 and -3 in place of a and b. So here we have 3 times 2 plus -3. So we begin within the parentheses before we try to square anything. 3 times 2 is 6, and then 6 plus a -3 is the same thing as 6 minus 3, which would equal 3. So within parentheses I have 3, and then that's being squared. So 3 squared would be 3 times 3, which would equal 9. One more example. We have y minus x to the 3rd power divided by 3x plus 1. So to evaluate, I plug in 4 and -2 in place of y and x. So here, instead of y minus x, I'm going to have -2 minus 4. And instead of 3x plus y, I have 3 times 4 plus -2. So from here, I need to simplify. Begin with parentheses first. So on the top, -2 minus 4 would be -6. So I have -6 to the 3rd power. And then on the bottom, 3 times 4 is 12. And then 12 plus -2 is the same thing as 12 minus 2, which would be 10. So I have -6 to the 3rd power divided by 10. So from here, before I divide, I need to do exponents. So I have -6 to the 3rd power, which means I have -6 times -6 times -6. So the two negatives become positive, then positive times a negative would equal a negative number. And then we do 6 times 6 times 6, and that would give me 216. So I have -216, and that is divided by 10. All right, and when I divide those two, I can simply move the decimal from after the 6 to after the 1. I move it 1 decimal place because there is 1 0 I'm dividing by. So my answer becomes -21.6. So the key is make sure that you follow order of operations as you work with exponents.